Okay, three things to cover today. Rectangles, rhombus, and squares. Which one you want to do first?
Rhombus.
A rhombus? Okay. Before I draw a picture, do you have any idea what a rhombus is? Tom,
It's like a shape that.
good start.
It's a polygon.
It is a polygon, good. It's got sides, no curved edges. It's a closed figure.
It's got. It's. This is a rhombus, right? I know how to. Wait, what?
What are you, voguing?
Yeah.
We talked about that already, didn't we?
Yeah.
Yeah, okay. I'll check.
It's a quadrilateral.
Oh, good, good. Yeah. Anything else?
Has four sides.
It does, good, because it's quadrilateral.
Oh, sorry, I didn't.
Quad, four, lateral,
Yeah.
side. Yeah. Okay. Anything else? Okay, I'll draw you one then. All right. That's a rough sketch of a rhombus. Brandon, what do you got?
All the sides are equal.
Beautiful. All the sides are equal. So I guess what we need to do first, before we continue, is come up with a definition. And then once we have a definition, then we'll talk about all the properties that are true for a rhombus. Use it.
Wait, can I just say something else? Like instead of the.
Well, it depends on what you want to say. If you want to call me a bad
No.
name, no.
No, I mean like.
If you want to tell me your life story since you were a little boy, no. If you want to tell me something relevant to this problem, yeah.
Aren't the opposite angles congruent?
Are you asking me or you're telling me? Because you just said, can I tell you something else, but then you asked me a question. So are you asking me or telling me?
I'm asking you.
You're asking me. What are you asking me?
Are the opposite angles congruent?
I don't know, are they?
I don't know either. That's what I'm asking.
What do you guys think?
I think so.
Yes.
You think so?
I also agree.
Okay.
Probably. Oh, art.
So, yes, Matt? Did you have an epiphany?
Isn't R and O congruent because the lines are pointing to the dashes?
Oh, yeah, they're opposite.
Don't you love when
They're
the lines are
opposite
pointing
of
to
It can make two isosceles triangles.
That's what I'm trying to say.
Two isosceles triangles?
Yeah.
How so?
If you just cut it in half.
Cut it in half this way?
Yeah.
Okay, so you want to... Matt, you started. You want to go up and down, or?
I want to go.
So you want me to connect?
Since Tommy helped me, I want to go
Yeah.
side.
That's what I
It
thought.
doesn't matter. There's still.
I just think it's.
So what kind of triangle is MRH and MOH?
Isosceles.
Isosceles, good. What else do you know about those two triangles?
They're congruent.
They're congruent. Why? Yeah.
Um,
Got a couple options.
yeah, you could do side, side, side.
Perfect. Now, if those two triangles are congruent, then what do we know about angle R and angle O?
They're
They're congruent because of CPCTC. Okay, so now we have that angle R is congruent to angle O. All right, let's change colors here. What if we ignore the red for a second and put in just the green guy? Same scenario, so that would get us then that angle H is congruent, is congruent to angle M. Okay, so let's stop for a second. With those markings on the board, what else can you tell me about RHOM? From what we did yesterday. Yes, sir.
It's not a parallelogram.
I'm sorry, that's incorrect. It is a parallelogram, excellent, because if it's not a parallelogram, it's false, then a nod would be, yeah, correct, it's a parallelogram. So that's rule number one. Numero uno. It is a parallelogram. Which means that anything that applies to a parallelogram applies to a rhombus. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, consecutive angles are supplementary, etc., etc., etc. The question is, what distinguishes a rhombus from just a plain old parallelogram? So now we're getting into the whole dog's golden retriever thing again. Do you remember what I'm talking about?
If a dog is a golden retriever, then a golden retriever is a dog.
All golden retrievers are dogs, but not all dogs are golden retrievers.
My bad.
So are all rhombuses parallelograms?
Yes.
Yes. Are all parallelograms rhombuses?
No.
No. Okay, good. What do you got?
Oh, I was just, is it because all the sides are equal?
Okay. Number 2. All sides are congruent. Okay. And while we're listing these things, the question you want to be asking yourself is how are we going to define a rhombus, and what are we going to make a property of rhombi? Rhombi? Yeah, that's plural. Rhombus is rhombi. Or rhombuses. Both of them are correct. I don't know why. Okay. What else could be true about that bad boy? Natalie?
For a definition, could you say a parallelogram when all sides congruent to each other?
That work for you guys?
I'm just asking him.
I understand. Does that work for you guys?
Yeah.
Okay, so we'll do it over here. Definition. A parallelogram with 4 congruent sides. Okay, so this would be true because of a definition. This would be true because of a definition. The other things that we list will all be properties of a rhombus. So they have to be something that's unique to a rhombus that's not true for a parallelogram. So again, what makes a golden retriever unique as a golden retriever, not just a dog? Okay, 4 legs doesn't work because dogs have 4 legs. Furry doesn't work. All dogs are furry.
No.
No, there's dogs
Negative.
there.
Hairless dogs.
Some people like shave their dogs, you know.
Yeah.
But that doesn't make it,
But there's
Hairless.
dogs.
Chihuahuas.
that's just,
No, you said furry, not hairless.
yeah.
Does
I
it,
think I should just stay in bed. You know what I mean? Just hit snooze. Sitting at home, watching The Price is Right now. But no, I'm here arguing about hairless dogs. When I'm supposed to be teaching geometry. Great. All right, anything else about the rhombus? Go.
It consists of 2 isosceles triangles.
Okay, so when we talked about parallelograms and we split a parallelogram into triangles, we got just plain old triangles. In a rhombus, the diagonal splits it into 2 isosceles triangles. I like that. But there's more, so before I write anything down, we're going to build more on those triangles. What she's saying is when I drew in that red segment, it split the rhombus into 2 isosceles triangles. When I drew in the green, it split it into 2 isosceles triangles. What happens when they're both up there? For discussion purposes, let's call this B. What can you tell me about triangles MBR, HBR, OBM, and OBH? And you're just guessing here because obviously there's no proof of what you want to guess, Natalie?
They're all equal to each other.
They are.
I mean, they all the sides of the triangles are congruent.
Which makes them all congruent to each other. Yeah, so when we split the parallelogram with the diagonals, we got 2 pairs of congruent triangles. All 4 of these triangles are congruent. Not only are they congruent, what kind of triangles are they?
Right triangles.
Right triangles, correct. Which means that this bad boy is perpendicular. Diagonals are perpendicular. That's a property. And based off of that, diagonals form 4 congruent right triangles. And notice I didn't bother listing any of the things with parallelograms because that's already implied in step 1. So I didn't say that the diagonals bisect each other. I didn't say that the opposite sides are parallel, et cetera, et cetera. You said, what do you got?
Also, isn't the midpoint same distance from all the midpoints of the sides?
No. Are you, if I understand you correctly, are you saying that RB, OB, MB, and HB are all congruent?
No, like B is the same distance from all the midpoints of the sides. Like the midpoint of RH and like from there to B is the same distance as from the midpoint of RM to B.
Yeah, they'd have to be because they're medians of congruent triangles. Matt?
Is RB congruent to BO and MB congruent to BA?
Yes, because it's a parallelogram, but not because it's a rhombus. Okay. There is one other small thing, which might not be obvious. Well, it should be obvious, but we skipped over it. When we drew in the first red triangle, and if you just look at triangle RMH, you said it was isosceles, so this angle would be equal to that angle. This angle would be equal to that angle. And this angle would be equal to this angle, and this angle would be equal to that angle. By doing the isosceles triangle thing a couple different ways. How do I summarize that? What are those diagonals doing? Yeah, diagonals bisect the vertex angles. Anything else? I think we pretty much got it all under control. So 2 through 5 is what makes this rhombus special or separate from just a plain old parallelogram. The other things for parallelograms are true, but this is above and beyond. Okay, let's do a rectangle next. It's easier. What's a rectangle? Franny, what's a rectangle?
Quadrilateral.
It's a good start. What else?
Polygon.
Good. Because it's polygon, it's got to be a quadrilateral, because all quadrilaterals are polygons, but not all polygons are quadrilaterals. Go retrieve your dog. Anything else for me? That's it? Can you draw one? Put your hands down. You want to label it? I didn't think that would be such a challenge. More? Sorry. Or rum. Okay, so why did you draw it that way? Because that's what you know what a rectangle looks like? So why didn't you draw it looking like a parallelogram? What makes a rectangle different than a parallelogram? Or what does a rectangle have that a parallelogram doesn't have? You drew it. Yeah.
All interior angles are 90 degrees.
Beautiful.
All angles.
So you drew it that way, you just didn't know what you were drawing. Good. All right, so we need a definition first. Franny, is that a parallelogram?
Yeah.
You don't sound very confident.
Yeah.
Do you want some help?
Yeah.
Is that a parallelogram?
Yes.
Okay, good.
Yeah.
It is, what am I doing? A parallelogram with, we heard enough out of you. No. No, no. Sure. I haven't heard from you yet today.
4 and
congruent angles that are 90 degrees.
Yeah, we could just go 4 right angles. We know that they're interior. Okay, so number 1, it's a parallelogram. Definition. Number 2, 4 right angles. Definition. Okay. What else makes a rectangle special? What separates it from all the other dogs? What do you got?
It has 2 pairs of congruent sides.
Yes, but so does a parallelogram. I'll give you some help. Franny, what do you want to call that point of intersection?
Q.
Okay. Now, we already know that MQ and QR are congruent. We know that EQ and QD are congruent. What is special about this rectangle, though?
Is it the same distance from every angle? The midpoint?
Yes, meaning what?
That all the diagonals are congruent.
Beautiful. Diagonals are congruent. That's a property. So MR is congruent to ED, which then means that EQ, MQ, DQ, and RQ are all congruent. So this equals this equals this equals this. Anything else? All right, what?
It forms 4 isosceles triangles and 2 right triangles.
Close. 4 isosceles triangles, 4 right triangles. You're shaking your head at me,
Yes, you
mister.
can do like
I'm a trained professional here. Yeah, so you got it, 4 right triangles.
Yeah.
Yeah, and 4 isosceles triangles.
Yeah.
Okay, good. So let's talk about the let's go back to the rhombus. The rhombus, the diagonals are perpendicular. Those diagonals perpendicular?
No.
Nah. They could be, but that comes up later. Do the diagonals bisect the vertex angles? Is angle DMR equal to angle EMR? For those of you that are visual learners, is this angle equal to that angle? Nope. Nope, nope, nope. Anything else? Okay, good. Not a very exciting figure. Let's move on. Get the last one done. What's a square? No, no, no.
A quadrilateral polygon with 4 congruent sides and 4 congruent angles. I think it's also a parallelogram.
You think or it is?
It's also a parallelogram.
Is it a parallelogram?
Yes.
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 Parallelogram with 4 congruent sides. And you want to go with 4 congruent angles or 4 right angles because it's a 360.
Either or.
Which would you
Your
prefer?
preference.
You wrote it.
Just 4 congruent angles.
4 congruent angles. Und 4 congruent angles. Which you should also be aware that they are in fact
Right angles.
Right
90
angles.
degrees.
okie dokie. Number 1, 4 congruent sides. Number 2, 4 congruent angles. Oh, I forgot parallelogram. Number 3, parallelogram. So definition, Definition number 4. Yeah.
Every square is a rectangle, but not every rectangle is a square.
What? Say
True.
say again?
Every square is a rectangle
Why?
because a square is a parallelogram with 4 right angles and all diagonals are congruent.
You didn't answer my question.
So
You
that's-
said all squares are rectangles,
yeah,
and I said why?
because I just told you they are both parallelograms. They both have 4 right angles and
Stop. What did you just say?
they are both parallelograms and they both have 4 right angles.
Done. In order for something to be a rectangle, it's got to have 4 right angles, right?
Yeah,
So that has 4 right angles,
yeah,
so that's a rectangle.
yeah,
Okay, what was the other thing you said?
but not all rectangles are square.
But not all rectangles are
Yeah.
squares, because not all rectangles have,
4 congruent sides.
okay, good.
That's what I was about to say.
Ah, okay. Any other revelations like that? Ooh, I don't know. Are the diagonals perpendicular?
Yes.
No.
Yes.
No.
Look at it.
Don't trust the picture. Pictures lie.
Maybe.
That is.
Yeah.
They are. They are.
Well,
They are.
yeah, I think so.
Yeah.
You look at the side that they are.
Can you prove it?
Yes.
How?
Because each side is 90 degrees, so 90 divided.
Sides can't be 90 degrees. Angles
the
can
angles,
be.
the angles.
Each angle is 90
Angle
degrees.
90 degrees. So
Yes.
you divide it by 2,
Uh-huh.
which is 45.
Uh-huh.
So that for the highest triangle, FR midpoint would be T. Just put T there. So for FRT, F is 45, R is 45. So that means T would have to be 90.
You're saying that's 45?
Yeah, because 90,
Why again?
because it bisector. It's a bisector.
How do you know that? So you're saying that GR bisects angle R?
Yeah,
How do we know that?
because it's a definition of bisector.
How do we know it's a
You're a moose. Why? Definition of moose. You're jumping the gun here, Sparky. Did you want to say something, or are you just going through some complicated yoga routine back there?
I had it, but then I forgot what I was saying.
That happens sometimes.
I had it.
Do we agree with this statement that it's a rectangle?
Yes.
I think I remember now.
Go ahead.
It bisects the 4 vertex angles.
How do you know that? Huh? I'll give you a hint. What kind of triangle is that? Isosceles, and the vertex angle is 90. 180 minus 90 is 90 divided by 2 makes each of those angles 45. And you can repeat that process with the other triangle and you realize that all of these are 45. All right, Tom, we just proved what it was you were using to prove what the other thing you were trying to prove, so now what?
So now each triangle's angle sum have to equal 180. So you do 180 minus 45 equals 90. So that means T equals 90.
Okay. So now we have it. Yes? Go ahead.
Is it a rhombus?
Is it a rhombus?
No.
Well, let's see. It's a quadrilateral. It has 4 equal sides. The diagonals are perpendicular. The diagonals bisect the vertex angles. Is that a rhombus?
Yeah.
Yeah, you bet it is.
Right on.
Okay, so now here's the big question. Is there anything in that square that's not covered by a parallelogram, a rectangle, or a rhombus? Well, let's pick something. It looks like the triangle GTO is a right triangle. The diagonals are the diagonals are splitting that quadrilateral into 4 right triangles. Well, that's true of a rhombus. That doesn't work. 4 sides are equal. That's true of a rhombus. The opposite sides are parallel. That's true. But so we got it covered. Okay. We good? If you think it's true, it is for a square. Which leads us to, what time is it? All right, we got time. Something called a hierarchy. What's a hierarchy?
Kind of like a ranking of positions.
For instance?
I guess in this example it'd be like rectangles, rhombuses, parallelograms, and squares.
Yeah, something other than geometry.
I don't know. Probably ask someone else.
You could do like government or like kings and queens.
Nice. Who's at the top of, well, which one you want to do? Monarchy or like our government?
We could do our government.
Who's at the top of our government right now?
The president,
Right. Okay, and below him?
the vice president,
Do you know who's next after that?
the
Speaker of the House.
That one blonde.
That one blonde, right. Right, so the president and the vice president are killed in a fiery bus crash. They're just going, get that blonde dude over here. You're in charge, buddy. You know who it is next?
No, I'm not sure. Is it like the House of Representatives or something?
Speaker of the House.
Here we go. Yeah, that's me.
Yeah. And the funny thing is that when Ronald Reagan was shot, you know who Ronald Reagan was, right?
Yeah.
When Ronald Reagan was shot, I can't remember the guy's name. He was not the Speaker of the House, he was Secretary of State or something, stood up at a press conference and said, okay, the vice president's out of the country, the president's been shot, I'm in charge. And they're like, oh, no, get out of the way, buddy. It's not you. Okay, so then president, vice president, blah, 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 blah. Who's at the bottom?
Like
Us.
Us, right, the peons. Okay, good. That's what we call a top-down hierarchy. So most specific at top, most general at the bottom. Monarchy would just be king or queen. I don't even know how that works.
King.
like
The vice queen.
princesses. No, it's
Then
the
the
princesses and the
speaker of the
princes.
court.
Princess and
Then the
princes.
Military, church.
princes,
Yeah,
Queens,
princes and princesses.
dukes, barons,
Pheasants.
pheasants.
Peasants are the lowest.
I
Above
meant
peasants.
Peasants and pheasants. Well, peasants might have pheasants. The serfs, if you will, the peons. Right. Okay. Any other hierarchies? Again, that's a specific to general. So top is the king or queen. The bottom are the peons, like you and me. You're all in bio, right? Have you done a hierarchy in biology yet? No.
Yeah.
Probably wasn't big.
Not in this bio.
It was like the two alleles dominant and recessive dominant takes over.
Well, you're using all kinds of words I don't even understand.
Ali.
Like alleles genetics. If they're both recessive, then you'll get that gene. If you have one dominant, one recessive, the dominant takes over because it has more powers. And it takes
So who would be at the top of that hierarchy? The dominant?
Dominant.
The brown eyes over the blue eyes.
That sounds like it would work. I know nothing about that. That's why I went into math. I was thinking more kingdom. Have you done that yet?
Oh.
Phylum, genus, kingdom,
like the first
whatever that thing is.
Yeah, I know you're talking about.
You did that, right?
Yeah, that was a really long time ago.
Yeah,
though.
yeah.
All right. So, anyways, all right. So we want a hierarchy for our quadrilaterals, but we're going to flip ours over.
Oh no.
So we're going to start at the top with a polygon, and then from a polygon go down to a quadrilateral.
So it's general to specific.
And yeah, we're going from general to specific. And let's list all our things here. So we got quadrilateral, we've got parallelogram, we've got rectangle. I don't want to do that. I'll break the course. Rectangle. We've got a rhombus. We've got a square. What am I forgetting? Is that it?
Yeah.
Oh, yeah, we cover more later. Okay. So off a quadrilateral, we have, of these four, which one is most general?
Parallelogram.
Parallelogram. So we'll come down here, parallelogram. We're doing okay so far? Yes, sir?
Could be a square next.
Square next? Square most general?
Yeah, I think so, because it's around.
Rectangle.
Rectangle. Where does rectangle go? Below here? Rectangle. Whoops, rectangle. All right, what next? Rhombus. So rhombus down here. And then where does the square go?
At the very bottom.
At the bottom. Okay, you're going to be angry with me. That's wrong.
Then why don't we just
Why is that wrong?
square should be?
No?
Wouldn't rectangle and rhombus be like equal?
Okay, so how do I represent that graphically?
You would do 2 lines from the polygon, or not polygon, parallelogram. That's fine.
Sorry for those of you that take notes in pen. My bad.
And then you could do
Which one do you want? What do you want to put on the left?
rectangle,
Rectangle over here, and over here,
rhombus,
rhombus. Okay, now the big question: where does square go?
right underneath them with 2 lines going to square.
Oh, look, it looks like a rhombus.
Wow.
Wow.
See that?
Yeah.
Top 10 observations of the year. 2017 is going to be a great year, guys.
Dylan, explain to me why you split these two in separate, at the same level, but we couldn't have one big column.
Because they're both parallelograms. But they're both parallelograms, but neither of them are like fit into each other's category. But then squares fit into both categories, so they have to be separate.
So if we look at parallelograms as being dogs, we've got golden retrievers and
Labradors.
Labradors.
And then a square is like a mix of both.
And then, oh, here, better. We have Labradors and poodles, and therefore we have a Labrapoodle.
Yeah.
How about that? Labradoodle, yeah, I forgot.
Labrapoodle.
Right, Labrapoodle.
Labrapoodles.
By the way, did you see in the news the guy that created Labradoodles said he regrets it, that he feels like he's created the Frankenstein of dogs? I'm not kidding.
So sad.
It was just in the news like 2 days ago. Yeah.
This
He-
world is great. 2017 is a great year.
Okay, now there's more to add to this hierarchy, so make sure you leave some room. We've got 3 more figures to talk about, but for now this will get us done. Okay, and remember the bottom is most specific. Specific. And the top is general. So we did ours upside down from the examples that we talked about. General to specific. The square at the bottom, everything that's above the square has the same properties. So if it's true about a quadrilateral, it's true about a square. If it's true about a polygon, it's true about a square. You pick any one of those figures, and those figures have all the properties of everything listed above it. So a rhombus is a parallelogram, a quadrilateral, and a polygon. A parallelogram is a quadrilateral and a polygon, etc., etc. Okay, so it goes up. We good? All right. So tonight you're going to see a lot of problems that involve algebra. For instance, here's a shape. Here's an algebraic expression for one part of a diagonal. Here's an algebraic expression for the other part of the diagonal. The other thing you're going to be doing tonight is you're going to be figuring out what kind of figures a quadrilateral would be. My hint for you is going to be not only do you have to prove what it is, you also have to prove what it isn't. Does that statement make sense? I have a figure. Let's suppose I prove it's a rhombus. I can't stop there. I also have to check to see if it's a square. So I not only have to prove that it's a square, or I also have to show that it's not a square. So there's 2 steps there. Show what it is, also show what it isn't. Question?
You have to do the drop box.
Thank you.
You're welcome.
And there's also, notice on the homework tonight, there are two worksheets. There's a 5.1 and a 5.2.